Hola amigos, my name is Diego the Explorer, and today we're going on a golden adventure to find the three sugars, which are all alkyne, alkene, and alkane. Hydrocarbons are organic compounds made up of only carbon and hydrogen. Are you confused yet? Well, don't worry. Today we're going to go on an adventure, and I have Bako and Boot joining us. That's enough for now. Come on, vamonos! Oh my god, there's a river. What am I going to do? Look, there's a sign over there. Let's read it.
Alright.
It says that if you can explain what an alkane, an alkene, and an alkyne is, a magical bridge will appear and we can cross.
That's okay, because I know what those three are. An alkane is a hydrocarbon with all single bonds. An alkyne is a hydrocarbon where one carbon-carbon bond is double bond. And an alkyne is a hydrocarbon where a carbon has a triple bond with another carbon. Look, a magical bridge appeared.
You go first, Diego.
Okay, Bako.
Bako.
By the way, Bako, what do alkanes even look like?
Hold on. I think I have something in my Bako.
Anyway, an alkane can be straight-chained or branch-chained. If it's straight-chained, that means it has a linear hydrocarbon formula. But if it's branch-chained, that means that some other groups are taking the hydrogen away, and those are called substituents.
So the substituents are groups of carbons and hydrogens that take the place of the hydrogen on the main backbone?
Yeah, you got it right!
Yeah!
Yeah!
Anyway, alkanes are non-polar molecules because they only consist of carbon and hydrogen single bonded to each other. They also typically have low boiling points because the dispersion forces between alkanes are very weak.
You know, Bako, sometimes I hear about unsaturated and saturated hydrocarbons. Can you explain that to me?
Well, alkanes are usually called saturated hydrocarbons because they contain as many hydrogens as possible. However, alkenes and alkynes are sometimes called unsaturated hydrocarbons because their double or triple covalent bonds can be replaced by more hydrogens bonded to the carbons.
Let's continue on our journey.
Well, I don't think we can pass this wall. What are we gonna do, Diego?
I don't know, you tell me, Bako.
Well, I think the sign says that we have to explain what structural and stereoisomers are, and then we can pass.
Well, a structural isomer is a molecule that can have the same structural formula, but can be arranged by itself in a different way. For example, butane, C4H10, can have a 4-carbon backbone, or it could be arranged with C3 and 1 carbon substituent. Bako, you know a lot about stereoisomers. Why don't you tell us about that?
Well, a stereoisomer is a special kind of structural isomer. A stereoisomer has the same molecular formula, and it also has the same order of atoms. However, the orientation of these atoms are different in 3D space. So there are two different kinds of stereoisomers. There's geometric isomers and there's asymmetric isomers. However, let's talk more about geometric isomers. Geometric isomers can be called cis or trans. The cis isomers mean that the substituents are on the same side of a carbon double bond. However, a trans configuration means that the substituents are on the opposite sides of a carbon double bond. Look, the wall has opened. Let's pass. Come on, Boot, let's go.
Yay, we made it!
Diego, where's Boot?
I don't know.
Rawr! I'm gonna eat you unless you tell me what functional groups are. Look what happened to this guy.
Bako, what are functional groups?
Well, Mr. Troll, functional groups are special groups of atoms within a molecule. Each functional group has its own specific chemical properties. They are also responsible for determining how the entire molecule behaves in a chemical reaction.
Well, alcohols have an ROH structural formula, meaning they have an OH attached to the carbon backbone. This makes the overall atom polar because oxygen is more electronegative than hydrogen. This makes most alcohols very polar and makes it possible for hydrogen bonds to form. Now, Backpacker, can you tell me a little about esters and carboxylic acid?
Well, first I'm going to talk about carboxylic acids. Carboxylic acids have the functional group COOH attached to the rest of the molecule. This carboxylic group actually consists of a carbonyl group and a hydroxyl group, which is the carbonyl group is the carbon atom double bonded to an oxygen atom. And the hydroxyl group is the oxygen bonded to the hydrogen that we mentioned before. So, carboxylic acids, because they have this C double bonded to the O, and also the hydrogen hydroxyl group, they usually form dimers in non-polar conditions, which means that they tend to bind to another carboxylic acid. Carboxylic acids are very polar, but they usually have very high boiling points because of this tendency to form dimers with itself.
Right.
Now let me talk about esters. Esters are derived from carboxylic acids. So, like I said before, carboxylic acids have the COOH group. However, in esters, the last hydrogen is replaced by another hydrocarbon chain. So, the ester still has a C double bonded to the oxygen. However, instead of the hydrogen at the end, there's a hydrocarbon chain. This replacement of the hydrocarbon chain means that esters can no longer form hydrogen bonds. However, the C double bonded to the oxygen means that the esters are still polar and that they can still form dipole-dipole interactions. However, because they cannot form hydrogen bonds, they usually have lower boiling points.
Ah, you defeated me. But I'm still not gonna let you through.
Go, Diego, go!
Yo!
Diego, I think we're almost there. Look, I can see the 3 golden sugars.
Now, Paco, we found all 3.
Yay! Good job, Diego!
Soldier Boy Dre. Oh, we made it.